astronomers have made the first observation of a planet orbiting a white dwarf, a remnant of a star's death, 6,500 light-years away. Models have previously predicted that such a planet could exist in a similar orbit, but no observations have confirmed the existence of one before. The observations of the planet called MOA 2010 BLG 477 LB were first made using the technique of microlensing, a kind of gravitational lensing where light from a star is bent due to the gravity of the planet to create distorted images or multiple copies of the same image at different points in the sky. The findings are thought to be analogous to what is expected to occur in our own solar system, as the Sun eventually becomes a white dwarf 5 billion years in the future. A different team of astronomers discovered the first planet to orbit a white dwarf last year. But that planet, WD 1856b, is thought to have been at least 50 times further away when its host star devolved into a white dwarf. Additionally, the planet is 14 times the mass of Jupiter, and currently orbits around its white dwarf every 34 hours. But the newly discovered MOA 2010 BLG 477 LB survived this transition in its own orbit, a more likely outcome for planets a certain, safe distance away from their star. Our own Sun is expected to reach this fate. After all the hydrogen is fused into helium, the Sun will expand into a red giant, accumulating carbon and oxygen in its core. Subsequently, when it runs out of nuclear fusion and dies, it will start to shed its outer layers, forming a nebula around the carbon-oxygen core, which is the resulting white dwarf. A white dwarf is extremely hot when it forms, but because it has no more fusion and thus no source of energy, it starts to cool. Too cool for infrared detection, the planet MOA 2010 BLG 477 LB was first detected through microlensing, a widely used method to detect exoplanets that does not rely on light from the host star to detect passing planets. The microlensing event, named MOA 2010 BLG 477, was first observed at Mount John Observatory, New Zealand, in 2010, and subsequently seen by 20 other telescopes in other parts of the world. Follow-up observations were attempted using the infrared telescope at the Keck Observatory in Hawaii for 3 years, from 2015 to 2018, but a host star could not be observed. The astronomers concluded that the planet was orbiting a white dwarf that was too cool to be detected by infrared. From their observations, the team concluded that the white dwarf had a mass about half that of our Sun, and the planet is roughly the mass of Jupiter. The planet orbits at a distance of roughly where our solar system's asteroid belt is located, making the entire system analogous to the Sun and Jupiter. The findings confirm for the first time the theory that Jupiter-like planets in Jupiter-like locations, orbiting Sun-like stars, can survive the stellar death of their host star in their own orbits and continue to exist in stable orbits around the remnant white dwarf. In our own solar system's future, the Sun will likely consume the inner planets, but this exoplanet, a planet outside the solar system, shows that planets beyond Jupiter will likely survive its death.